The night sky appears to be serene and organized. Be that as it may, in reality, stars are tilting through the system at rates of a huge number of kilometers each hour. Not limited by static developments, they are changing neighborhoods continually. Luckily, space is large, and thus the stars of the Milky Way are probably not going to hit us. Tragically, they don't need to hit anything to make us have a downright horrendous time on the planet. Also, there are already stars beginning to get extremely close. To comprehend how perilous stars are as far as we might be concerned, we need to discuss gravity. Gravity draws in each piece of matter to every single piece of matter in the universe. You are drawn in by a molecule 1 million light-years away, as well as the other way around. Fortunately, this power gets more fragile over distance, and it also really relies on how gigantic something is. So, things that are close and very monstrous are more attractive, winning the infinite back and forth. Thus, monstrous things define how smaller things act around them. The Sun makes up 99.75% of all the mass in the nearby planetary group, and so it shapes the behavior and orbits of all the other things in it. Billions of years ago, after the Sun was conceived, the solar system was a turbulent and perilous spot as the planets were formed from innumerable little pieces that impacted continually. However, over the ages, a steady equilibrium arose. Today, most planets and asteroids have sunk into safe and predictable orbits. We have the inner and outer planets, the asteroid and Kuiper belts. Furthermore, at the edge, the Oort cloud, a massive circle of comets circling slowly in cold storage. We truly don't want this equilibrium to be upset. Assuming another star came too close to us, its gravity would pull on everything in the planetary group like a ruined baby, wrecking the beautiful order of the planets, asteroids, and comets. This isn't some fanciful risk. Nearly a long time ago, a red dwarf, a brown dwarf binary system, passed through the Oort cloud and wrecked things. It could even have sent a lethal invasion of space rocks our way. However, it could take 2 million years until those guests from the Oort cloud show up in the inner solar system. In any case, there's a much more pressing issue on the horizon. Gliese 710, a red dwarf with about half the mass of the Sun, is currently headed towards the planetary group. In around 1 million years, it'll go through the Oort cloud and become the brightest star in the night sky. A close flyby like this would unfold over millions of years, upsetting the orbits of millions of objects in the Oort cloud extensively. If we are unfortunate, it will set off another wave of planetary assaults, like the early solar system. The night sky could be filled with comets and asteroids descending upon the inner solar system. The larger ones could cause dinosaur-level mass extinctions and would be terrible for the economy. In any case, it could deteriorate. The cosmos is a serious place, and stars draw close to each other routinely. So, it is conceivable that a star could draw a lot closer and not just pass us but fly directly through the inner solar system. This sounds extremely terrible in the limit. The chance of another star impacting with the Sun is cosmically impossible, however, that isn't the very thing we're stressed about. If another star were to pass by about as close as the Earth is from the Sun, it could effectively launch the Earth from the nearby planetary group. The chances of such an event are estimated to be around 1 in 100,000 in the next 5 billion years. Small, but not ridiculously so. As we talked about in another video, there seem to be billions of rogue planets doing their own thing in the universe, and this is one way to make them. So, if this were to happen with an average red dwarf, what might occur on the planet? Removing Earth from the nearby planetary group, as the star enters the nearby planetary group, a little orangish dot shows up overhead that becomes larger and more brilliant for a long time, ultimately becoming visible during the day. It would get greater and much more brilliant than the moon, too bright to even consider looking at straightforwardly. The night sky would be filled with a ghostly red glow. Following a couple of months, it would once again start contracting. However, so would the Sun. Over a couple of years, the Sun gradually becomes smaller overhead, and with it, warmth and light begin to scatter. From one side of the planet to the other, as the days turn dim, the last winter of humankind would begin. The polar ice caps start to develop and spread while plants wilt and die. Forests freeze, and animals die in large numbers. As the Earth passes the orbit of Mars, the normal surface temperature has plunged to around -50 degrees Celsius. From space, Earth begins to appear as a frigid moon, the blue-green surface becoming the pale dark white of death. As global infrastructure collapses, people crowd together inside, consuming what they can for warmth as the temperature continues to drop, counting the days until they'll be out of food that no longer grows. Everyone living at the surface is surviving by luck alone. When Earth arrives at Jupiter's orbit, surface temperatures sink to -150 degrees Celsius, lower than the coldest recorded temperatures in Antarctica. Obviously, at this point, nearly everyone is dead. Without the energy from sunlight to evaporate water, clouds don't form, and the water cycle stops. The polar ice caps eventually meet at the equator, and the seas become covered in a thick layer of ice. As more and more of its heat spills out, more water freezes onto the bottom of the ice sheet, the salinity in the deep sea increases, harming most creatures that manage to survive here. Although around hydrothermal vents, communities of extremophiles could adapt even to these conditions. Far beneath the surface, some microbes wouldn't see much of any of this, as they are still kept warm by the radioactive decay of elements in the world's core. As the Earth arrives at the orbit of Pluto and the Kuiper Belt, the Sun is still the brightest star overhead, but it is one among many, with stars now visible during the day. The temperature is now barely 40 degrees Celsius above absolute zero, below the freezing temperature of the gases in the atmosphere. A peculiar display, enjoyed by nobody, tragically unfolds as the atmosphere transforms into nitrogen and then oxygen snow. Over a couple of years, it is preserved into a frozen 10-meter thick sheet all around the planet's surface, with just a thin whisper of gas remaining. The frozen bodies of flora and fauna are buried beneath them. As Earth leaves the planetary group, it becomes a rogue planet, traveling solo through the dark, dormant and in isolation. However, abnormally enough, there is hope. Humanity wouldn't be surprised by this potential extinction event. We'd see it millennia ahead of time. There isn't much we could do to stop a star. Yet, we could prepare. The vast majority of us would die. However, a couple of million could survive in massive artificial buildings, powered by geothermal and thermal energy, potentially even fusion if we can figure out how to utilize the ice around us for power. Here, humankind could survive for thousands of years. Eventually, we would become accustomed to our conditions, and new generations would hear stories in dismay about the time we had our own star and could walk the surface of Earth. Furthermore, eventually, we could decide to search for another home. Assuming the Earth were fortunate enough to pass by another star with a habitable planet, we could attempt to make a new beginning. Spaceflight, strangely, would become extremely easy without the atmosphere in the way. So, it's not unbelievable that the last survivors would abandon Earth and try again on another planet, around another star. Perhaps one day, millennia later, the descendants of humanity will tell legends about Earth's ancient past, stories of our lost home, of a mysterious cold planet drifting alone and void through the dark of space. Thank you for watching. I hope you enjoyed this journey into the mysteries of the universe. If you found this video interesting, please give it a thumbs up and share it with your friends. Don't forget to subscribe to my channel for more amazing updates.